Alrighty, so this is kind of where we finished yesterday, and we are going to complete our notes for cosmology today. So again, when we look at the Big Bang and what it predicts, when we look out at our universe, it predicts normal matter. All this other stuff that supposedly makes up our universe, dark matter, dark energy, 96% of what the universe is supposedly made of, is patchwork. They have to input this into what the universe is in order for the Big Bang to actually work. The only evidence, and again, like I said yesterday, I don't mean to burst your bubble here, because dark matter, dark energy, it sounds so mysterious and so interesting. We want to learn more about it, but the only evidence for dark energy and dark matter is the fact that the Big Bang and its timeline does not work without them. And these aren't the only patches on the Big Bang theory. There's things like dark flow, dark fluid, and something known as inflation, which we're going to be talking about shortly here. Again, I showed you this yesterday. Over 80% of all matter in the universe is made up of material scientists have never seen. It's called dark matter. We only assume it exists because without it, the behavior of stars, planets, and galaxies simply wouldn't make sense. And what they mean, again, is it simply wouldn't make sense in the context of those billions of years of the Big Bang. So, a little bit more about what we would expect from a massive Big Bang explosion. If all the matter in the universe was at one time compressed into the size of a pinhead and then exploded in every single direction, you would have splotches in certain locations. The mass would not be evenly distributed. And what that means is that our universe, in and of itself, should be shaped a certain way. So there are really three possible ways it could be shaped. It could be shaped in a positive way. In other words, the universe itself would be kind of like a sphere. Or it could be shaped in a negative way. It could be shaped like a saddle. Or if everything was exactly, perfectly right, which would be an astronomically small chance of this, the universe would be even and flat. So it turns out that when we look out into the universe, it is not positively curved. It is not negatively curved. It is, in fact, nice and evenly flat and spread out in a way that we would not expect if it was the result of a chaotic Big Bang. So how do we fix this problem if we're in the scientific community looking at this? They use something known as inflation. Please write down the word inflation, but nothing else from this slide. So again, the scientific community knows and acknowledges that the Big Bang should not have created such an evenly distributed universe. It should be curved in one way or the other, in a big, big way, but it's not. So they say that inflation actually happened. And so the idea of inflation is this. And you don't need to write this down either. From 10 to the negative 36 seconds to 10 to the negative 32nd seconds after the bang from the Big Bang, the universe expanded by a factor of 10 to the negative 78th. Yeah. So again, this is a fudge factor that had to occur in order for our observations of the universe to be okay with the Big Bang theory and the 14 billion years of time that were fed here. So in other words, for this split second of time, it's a very short period of time. Before this time, gravity was normal, mass attracted mass. But for this period of time, gravity stopped behaving in that way. It reversed. Gravity started repelling things instead of attracting it. And it repelled them in such a way that it was like zillions of times stronger than the gravity that we're aware of today. And that occurred after the bang, and that expanded the universe by a factor of 10 to the 78th. evening it out, smoothing it out so it's nice and flat. So it starts for no particular reason. Gravity switches to a super strong repulsive force, and then after that, it goes back to behaving normally like we expect gravity to behave today. So this is something that's just thrown in there because our observations of the universe don't match with the whole idea of the Big Bang having occurred that long ago. You have to smooth out the universe artificially. And so when you see pictures like this in textbooks, that's what they mean when they're talking about inflation. The universe doesn't look the way it should if it was a Big Bang, so you have to have this magical reverse gravity inflation take place over this period of time to artificially smooth it out. Okay, from this, go ahead and write down these 2 bullet points. These are under the inflation heading. You don't need to write down "remember me." Sometimes I think we should have spelling contests in this class for some of the words we're going to be seeing.
You could do that and make the wins extra credit.
That's not a bad. That might be fun for like a little change of pace day. What's that? Yeah, I think that would be cool. Again, do make sure you're taking good notes. Your notes are where the test questions come from, so you want to make sure that you can read them. As you finish writing this down, I want you to imagine yourself somewhere. Imagine yourself in a swimming pool, and it's just the perfect temperature. All too often I jump into a swimming pool and it's too cold, and I hate that. But imagine you're jumping into one and it's exactly just right. And then, over on the far end, you see a dump truck backing in. And it's dumping loads upon loads upon loads of ice into that pool. Are you going to notice a temperature difference right away? No. It's going to take a while for that ice to cool down the rest of the pool so that you can actually tell the difference. Well, that's kind of where we're going here. And you'll be writing this down specifically in the next slide. Thank you. But when we look out in the universe, we see differences in temperature. And that's what this represents. The red represents warm temperatures, the blue represents cold. But these are not big temperature differences here. They're very, very small. The different colors represent plus or minus 200 millionths of a degree. So when we look out into the universe, what this is saying is that everywhere it's all just about the exact same temperature. Now, of course, there are stars in places, and in those exact locations, the temperature is warmer. But overall, when we look in the universe, if it was the result of a massive, catastrophic, chaotic Big Bang explosion, we'd expect splotches all over the place. 14 billion years is not long enough for this temperature distribution that we see in the universe to be here. It's like if you were in that swimming pool, all the ice dumped in the water, and you instantaneously noticed that the water was a different temperature. You know intuitively that it takes a while for the temperature to equalize for you to tell that difference. The same thing should be true in the universe. So when we look out into space, we see these temperatures being the exact same, and believe it or not, 14 billion years is not long enough for these temperatures to have equaled out to this extent. You can go ahead and write down all the bullet points here. You don't need to write I'm back, but start with horizon problem and then finish up with those. Yes, this is still for inflation. So again, when we talk about inflation, we'll often see pictures like this associated with it. You see the Big Bang at the left, and you see this inflation right here. And they need that fudge factor in order to make the universe look the way it needs to look. Without these things that are added without evidence, then the Big Bang does not explain what we see in the universe in many, 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 many ways. So this is kind of an interesting thing too, because, you know, when we look at things in our solar system and we look at things in other galaxies, we see the hallmarks of youth. But when we look at the temperature distribution around the universe, it seems like it's been here longer than the 14 billion years instead of less. And so what this really speaks to is it speaks to the really horrible predictive power that the Big Bang has. And when you start with the assumption that there is no God, that we have a universe that created itself naturalistically, it's no wonder we see results that are not only bad, but they contradict each other. That's the first sign of a really, really bad theory. We see that all over the place when we try and naturalistically explain our universe. Our willingness to accept scientific claims that are against common sense is the key to an understanding of the real struggle between science and the supernatural. We take the side of science in spite of the patent absurdity of some of its constructs, because we have a commitment to materialism. Moreover, that materialism is absolute, for we cannot allow a divine foot in the door. In other words, even though when we look out into space, and we look into our solar system and right at home, whenever we see arrows that point away from the naturalistic philosophy, the no God needed idea, and straight to that there is a designer here, the scientific community isn't going to entertain that idea because it is not materialistic. Science has relegated itself to explanations that do not require a God. And nothing could be further from the truth, folks. Alex, do you have a question?
Yeah, if you said that 13 billion years isn't time for the temperature to be so equally distributed, what is it supposed to look like?
It should be a lot more splotchy. We would expect to see, let me go back to the picture here. So maybe it would look kind of the same in terms of the color differences, but these color differences should be a lot bigger than plus or minus 200 millionths of a degree. You should have, you know, much hotter areas here, much cooler areas over here, certainly not this small of a difference. So in order to keep the Big Bang Theory alive, it has to constantly be patched up by made-up stuff. And there's actually a document out there because, I mean, when you look at, this is not rocket science. We're not looking at real sophisticated equations or real sophisticated observations here. The basic observations we make don't line up with what we would expect if the universe created itself out of nothing without a designer. And, you know, scientists realize this, and there's actually a document out there where they say, look, you have to be able to allow us to question the theory of the Big Bang. Because today, if you question the Big Bang or you question evolution in a university setting, you'll be, you know, laughed at, and you'll be scolded, because these are the foundations of science today. And so even though science goes against them, you're not allowed to question them. But not every scientist believes that, which is nice. There are some scientists who want to explore alternatives to it. And I can dig that document up for you sometime if you'd be interested. Fatal flaw of the Big Bang model of cosmic evolution is that it is based on unverifiable assumptions. After that, key evidences are explained by unknowns that cannot be experimentally verified. The Big Bang must be believed by faith because it falls outside our normal concepts of experimental science. We have only one universe, so we cannot test models for the universe by comparing it against other universes. The Big Bang cosmology is only verified in the minds of those who already hold to that belief that billions of years ago, the universe created itself out of nothing. Now, it's not like a biblical version of history is without big questions here, though. Because after all, when we see these galaxies and we see these stars, they're a long ways away. They're not just a few miles away from us. Then, like if you took the entire width of our solar system from here to Pluto, you would have to multiply that 4,000 times for us to reach the nearest star. So these stars are a long ways away. But the light from these stars and the light from these galaxies is traveling a finite speed to get here. So it should take a long time for that light to reach us. And this is kind of known as the starlight travel problem, or the distant starlight problem. Because if we believe the Earth is only 6,000 years old and the universe has only been around that long, how is it possible that light from stars and galaxies from millions of light years away could reach us in that time? That light should take millions of years to get to us. So how can we answer this question? And it's a big one. From this slide, go ahead and write down the bullet points and the title, but you don't need these sub-bullet points. So just the title, and then these 3 bullet points right here. So again, we have ourselves a very interesting question here. Now, a light year represents how long it should take for a beam of light to travel for 1 year. So if we see a star that is 1,000,000 light years away, it should take that light 1,000,000 years to reach us. But if the world is only thousands of years old, like the Bible implies, then how is it possible we can actually see that light? The answer to that question can actually be found in Scripture. Now, there are several answers to this question. I don't want to pretend like my favorite answer is the right one. There are 5 or 6 different ideas on how this light can travel that distance in that short period of time. For me, I'm kind of a simple person, so I don't look beyond answers that are simple and answer that question and are consistent with Scripture. So I'll just have you write it down. Ooh, we got to see that transition again. We're going to go back. Man, PowerPoint can really look cool. Go ahead and write this down. And then we'll talk. So in Genesis 1:11 through 12, we're given the description of what's happening on day 3 of creation, when God makes vegetation. God said, "Let the earth sprout vegetation," and it was so. The earth brought forth vegetation, plants yielding seed, and fruit trees bearing fruit. And I don't know how easily you can see this, but the words "brought forth" I have bolded here. So when you look at the Hebrew of "brought forth" that we translate to "brought forth," it kind of implies a fast forwarding here of maturing. So if you were standing there on day 3, you probably would have saw this vegetation and trees and plants sprouting right before your eyes, kind of like those time-lapse things that we see in nature documentaries. And so if God brought forth the vegetation by sort of fast-forwarding time and just bringing it forth on day 3, there's no reason whatsoever to think God wouldn't do the exact same thing the very next day on day 4 when he created the stars. He brought forth that starlight in the same way he brought forth the plants on day 3. Now again, there are other explanations for this. There are other creationist interpretations, and I have resources if that would interest you over there to hear some other explanations for how the light reached us in that amount of time. But this is my favorite explanation. So the last thing that you are going to write down is a summary of what we've talked about. And these summaries are super important. One reason is because it's what your final exam is going to be based on. So the other reason that they're important is because I know that 90% of what we've talked about over the last 3 days, you're going to forget after the semester is over. I would too. But what I'd really like is for you to have something to take with you after this class ends that you can sort of just have a quick reference on some of these things. So when you write down your summary for this and other chapters, I would like you to put them on a separate piece of paper apart from your notes. At the end of the semester, I actually have a whole day set aside for you to make a specialized little artistic cover for all of your summaries. So if you want to put all your summaries on separate papers, that's fine. If you want to put all your summaries on the same page and then just, add pages as you need, that's fine too. It's totally your call. But have a special place to write down these summaries right here. And this will be the last thing you're writing down for today and for your notes for this section. And as you're writing this down, I'm just going to say, as we look in the universe, we look in space, we look at other galaxies, and we look at our own solar system, what we always find here, and as you'll see in other chapters, is that a naturalistic, no-God way of looking at things runs into all sorts of problems. There are very basic, straightforward observations of our universe that do not match with that starting point, with that philosophy. But when we look at our universe through the lens of what God tells us through his creation account in Genesis, it matches up perfectly with what we observe in the real world and out in space. That shouldn't surprise us.